So we're going to look at the progression of maritime sailing techniques from the so-called ancient Greeks through modernity. And we're going to try and trace and see where exactly everyone transitioned to the world's a globe and this is how we sail. So let's see if we can't find it. Should be easy. So we start off with our boy Ptolemy, Ptols, right, putting forth the two-sphere model and the book Geography, also known as Cosmographia, right? This is the oldest known treatise on cartography and how to make maps. And this whole premise is that you have to envision the world as a two-sphere model conceptually, with an inner sphere of the terrestrial sphere and an outer sphere of the celestial sphere. We're going to go into his book a little bit because when we talk about ancient sailing, the first thing that you'll find if you look at Wikipedia or any of the mainstream sources is that everybody knew the Earth was a globe since 200 BC. That's what they'll start off with. But they're not going to say, oh, since 1700 we had a coordinate system. They're not going to say since the map came. They're going to say, oh, we've always known it's a sphere. The history starts way before, way at the beginning. We've already known. Anyway. So here's our boy Ptolemy with his armillary sphere over here that actually transformed into a flat disk somehow. He was, of course, he's the one who made this book, wrote this book, was an ancient Greek. He gets referenced by Herodotus and Eratosthenes and Hipparchus and a bunch of other ancient Greeks who reference each other. That's how you know they're real. But his major contribution to what we're going to be talking about as far as map making and maritime navigation is he's going to be credited with the coordinate system, right? Latitude and longitude. Looking at the father of the graticule right here, right? In his book, Geographia, he put forth the first marking of all the longitudes and latitudes of the known locations in, of course, stadia. But most of his book is just coordinate pairs and pairings of things that he knew and places that he knew of. In fact, if we look through the book here, it says it's the only book on cartography to have survived from the classical period, and is in the same sentence one of the most influential scientific works of all time. Right, written in the 2nd century AD. It was the most detailed topography of Europe and Asia available, and again, all referenced in stadia and latitude and longitude before they used it. How to gather data and draw maps, and that's astronomically. That's the process that Ptolemy used. It says he championed the astronomical observation and applied mathematics in determining geographical location. So he's going to be credited with the grid that's going to be the backbone of how people map and sail. Apparently. So again, Ptolemy's book starts with, before we can make maps and understand how to mark things, we have to accept the two-sphere model. We have to assume the reader understands and accepts the two-sphere model of the cosmos, the geometric terrestrial sphere, and then the conceptual heaven of a sphere of infinite radius concentrically around that with the celestial sphere, right? Pretty basic. Also of interest is Ptolemy is also credited with a particular map projection, right? Of the graticule, the father of the graticule came up with his second projection way back in the 2nd century BC, again, before we have coordinate systems, known projections, any of the maps that were said to, he's credited with creating this. And then, of course, this kind of hangs out from 2nd century BC all the way to 1516, and Gerardus Mercator comes along. So this is for 1700 years, they had exactly 2 map projections that only Ptolemy figured out in the 2nd century BC. That's the so-called correct historical timeline so far. Not exaggerating. So, when we look at all of antiquity, along with our boy Ptolemy writing Geographia and the father of cartography over here, the father of the graticule, we have these other 2 Greeks who are credited with foundational contributions to be able to map and make cartography work. Of course, back here, they were calling it cosmography still. But Eratosthenes, of course, which, used sun angles to measure the Earth size in big italics, parentheses, and air quotes, because what he did was get the circumference calculation using the sun angles by using a known distance between them, right? And Eratosthenes is also credited with an early latitude-longitude system. So along with Ptolemy, he was the father of the grid here to be able to make geographic reference in a spherical coordinate system known as latitude and longitude. We also have Hipparchus, who was the mathematical infrastructure for what Eratosthenes and Ptolemy were doing. He supposedly invented a type of calculus and trigonometry that made what they were doing mathematically plausible. But he's mostly not mentioned in here. It's just mentioned as the big 3: Ptolemy, Eratosthenes, and Hipparchus. So Eratosthenes, of course, credited with this wonderful measurement of Earth's circumference only by assuming parallel sun rays on an equinox and a rays of a sun into a well, and then knowing that 7.2 degrees difference of the angle of the sun divided into a circle by 360 times this known distance, 800 kilometers between Syene and Alexandria, is how he got his 40,000 kilometers. The thing I want to point out about here is that this is just a ratio with no actual earthly value until you plug in this figure right here. 800 kilometers is the only thing that gives this a value. This is just a ratio of the circle, and this is an angular measurement of the difference to the sun. None of these are going to give you the size of the Earth. The only thing that gives you a size of the Earth is this multiple right here, which, of course, Eratosthenes had already known. So then the story becomes, he measured the Earth by already knowing how big the Earth was. Right? He measured the Earth by knowing how distant this was. And the method, of course, was old bematists, which are geodetic surveyors of old. And that's what they tell you. But that, of course, is just a myth. None of that's proven. No such thing was ever surveyed. He just knew it. The story is the story, and there's the giant hole in that. So, to sum up antiquity, we got our three boys, the father of our old school mapping. However, everyone knew the Earth was a sphere. You got Eratosthenes with his latitude-longitude grid. That's here. That's him concentrating hard in the middle here. You got Hipparchus, figure out you can divide stuff by 360 mathematically. He's over here looking super proud of himself. And then you got Ptolemy, who wrote the book on the graticule and how to make the two-sphere model work with geodetic navigating. He's over here with his chin up. All right, so these three together have put forth everything that the world needs to, understand in sphericity and sail as if the world was a sphere. So then the question becomes, from the 2nd century BC all the way until 1600s, why the hell was nobody sailing as if the Earth was a sphere and everybody was sailing as if the Earth was flat? Because all of these people, Greeks, even though they accepted the two-sphere model, nobody honored this. Nobody was able to use this to sail. Everyone used plain sailing over all distances. So, of course, they had their latitude to be able to get from celestial observations and using things like the North Star. Also of note in this period are tools like the astrolabe, right? We have things like the sextant and, high-tech tools today, but in the old school, if the narrative can be believed, then this was the granddaddy of all astronomical tools. The astrolabe, it did everything, but of course it took elevation angles to the sky. So if they were sailing around their shores with an astrolabe, they were pretty well equipped, to be able to sail. If we add in what we find in later with Portolian maps and nautical charts and compass roses with windrose networks, then they're definitely prepared with just an astrolabe to go sailing without having to reference the known spherical model of the Earth with Eratosthenes and Ptolemy's GPS coordinates marked out in Stadia. Nobody navigated with those. Nobody needed them. Nobody used them for anything. They sat in a book for 2,000 years until we needed them, apparently. That's the story. So again, they used an astrolabe, which we know pretty much emulates the celestial sphere onto a plane using stereographic projection in a wonderful way. It has many parts and many different uses as we went over before, but we're going to be concentrating mostly on just how they can make angle measurements with it, right? Which is going to be the elevation scale right here. Over here, elevation of celestial objects above the horizon. This is exactly for determining altitude. Here it is a little bit closer, right? So here's what they would be using to guide them in the sea. And they're going to be taking measurements to Polaris to determine their latitude. And then they're going to be using basic nautical charts and a compass and directions to plot their known course in the sea. That's how everybody sailed. So they also use things called rum lines, and they have nautical charts from pre-1600. So every nautical chart prior to like 1600 is a combination of compass rose, wind rose networks, and rum lines. So we're going to say what this term here, rum line, is actually a term that gets redefined in modernity to specifically adhere to sphericity. But up until then, it's defined as something totally different. So we're going to go into that. This is just a line on a map that's used to plot courses that maintain constant compass direction. That's what it meant prior to modernity redefining it. We got questions.
I like that it's, second line, still first sentence where it mentions aviators as well. That's exactly what was in my mind when you were mentioning rum lines and the rose itself, because that's exactly what we see on small scale aviator maps. especially the stuff they were printing 50 years ago before all the jet lines were superimposed over the whole thing.
Really?
You see a lot of room lines town to town and just basic headings and away you go. It's yeah, uber simplified that way.
That's really funny. I haven't even seen that or considered it for aviation, but also that they would call it rumline and that they would try to redefine rumline as a thing that would adhere to sphericity is especially funny. Because obviously, if you look at the old navigation charts, then you wouldn't be thinking, "Hey, we need a spherical reticule to use this." You'd be thinking, "Oh, look how simple this is. I can get where I want to go." Right? So yeah, so this is a compass rose over here, and its connection to all the nautical charts. And historically, they had connection points where we're at the intersection of rum lines would serve as the origin from them radiate out in the surface. And we're going to look at a couple of these in detail in just a little bit. But the direction reference is the whole point for the compass rose and the rum lines on old school nautical maps. There's align their compass with the map, and then they could follow the correct rum line, which would be one of these lines. As they look at the map, they'd match it up and they'd follow it consistently on the compass, and they'd be able to follow the right direction to get to where they want to go. Now, more than one of these nodes, we'll call them, connects and creates a wind rose network, which is a connection of rum lines and compass roses on a nautical chart. So it's multiple rum lines radiating from multiple compass roses or portolan charts. It's called a wind rose network. Right, so let's go here. What we have is the portolan chart. This is the old school nautical chart. This is what mariners were using prior to 1600s and assumingly all the way back through the Greeks. Even though everybody knew the earth was a sphere, nobody sailed that way, apparently. So even though they had the backbone of sphericity and what Park put forth with GPS along that, marked all the known locations, put forth the projection type that was able to display sphericity, no problem. All the tools were there. Nobody used them. Everybody used these. So they have characterized by rumline networks, which we went over, and we'll go over these in detail. But here's a compass rose, here's a network, and then each one of these roses connecting to one of these other points, which itself then spreads out into other lines. This is what comprises a wind rose network. Interconnected rum lines into compass roses that creates a whole network. And of course, lines of network generated from compass to show lines of constant bearing. That's all these are meant to do, is match true directions in the real world with the aid of a compass or a compass rose. So again, based on magnetic directions and estimated distances, represented the whole Black Sea, Western Europe. They pretty much mapped out all of the Western world, aside from America, with these, as far as I could tell. All of Europe is mapped, most of Africa, right, if we go through them. And of course, the latitude is based on astronomically derived latitudes. And if this bottom part is fun, obviously this is Google AI, but the bottom part is my favorite. The theories of the origin and evolution of portolan charts are still being studied and debated. Meaning, we don't know. I guess they were just using them until those dummies didn't know the Earth was a sphere. That's literally what the mainstream model has put forth. Is this is certainly it worked. It was accurate. Doesn't require sphericity. Everyone used them all the time. But we don't know. We don't know where it came from, how it evolved, what it came. It just the historical record is. So here's one of these old school portolan charts close up, and you can see it has gently drawn in country lines. You can see this is Italy, right? This is the boot of Italy extending off. So then what we have is a coastline here, a coastline map. And you can see that if you're going to sail across somewhere, you could find your bearing on a compass rose. This is really zoomed in. And you could just find your direction, and you want to get to the city, then you follow this line, this bearing all the way along here. And that's how they did it for the most part. And all of the charts are like this. So they all use rum lines with a compass rose to create a wind rose network. And again, rum lines are maintain constant compass direction. And this is the old school definition that we're dealing with still. We haven't yet redefined this term rum line in modernity, but we're getting to that. For right now, they just still mean the lines used to plot and maintain constant compass direction. That's pretty much what they would. So then later they get redefined as the shortest distance between 2 points on a great circle that spirals outward. Irrelevant to what we're talking about here, but a funny redefining term in modernity. So again, all early nautical maps were pretty much portolan charts. So all nautical maps featured networks of rum lines radiating from compass roses. So we don't know where they came from or how it happened, but everybody used them in all the maps worked this way up until we had sphericity. So over here to our next example of a portolan chart, we have another compass rose. We have, I think this is, I don't even know what language this is, but more or less the same representation. One compass rose over here, another intersection over here, and you got one over here, and there's one over here, just less zoomed in. Same principle applies, right? You can see how if you were trying to find this island from anywhere over here, you'd be able to follow one of these compass bearings to closely get to where you're trying to go. They do seem to be a little bit more artistic here, right? We have the drawings on the side, and we have meticulously stylish compass roses coming out. Some of them have more than one bearing, some of them have less bearings. Of course, this is kind of a varying example. Again, of course, we have Italy over here, I think. This would be the boot. And then we have most of Europe being represented in colorful cartography with heavy windrose network. So all of the world, when you were sailing, you use this sort of navigation, map, and network. And again, over here, we have another example, a little bit older. I'd like to zoom in on what's on the side over here, but we have, say, Indian charts. It looks like old school Asia, maybe? Same sort of, same area, different representation, same style, and the basis for all nautical charts. You know, they have different islands mapped out, etc., but same principle. So everyone, all over the world, through all of antiquity prior to 1600, uses nautical charts like rum lines with compass rose networks, but nobody knows where they came from. And after all, don't forget, at this time, everybody also already knew the Earth was a sphere and had all the tools for sphericity and for spherical mapping and for coordinate system transforms and had all the GPS long locations for everywhere they wanted to go. Again, 2nd century BC, yet everybody navigated this using rumline network. So that's an interesting juxtaposition to me. And again, rumline network right from Wikipedia is also known as a windrose network, navigational aid consisting of lines from multiple vertices in different directions, forming the web-like mesh. And it's from nautical charts. They call it the medieval age and the age of exploration, but it's for all maps prior to this, the Mercator. And we'll get into that. And again, rum lines are extending outwards across the map, derived from how the maps were made when compiling empirical observations from navigators who attempted to follow a constant bearing at sea. So they're describing how they think rum lines were created. That the multiple compass roses straight lines were created by people comparing real world bearings with where they were going and then compiling that data. I think that's a pretty good guess as to how they would have created these. There's been some speculation that maybe there's an astronomical time with some of these points and where you would choose to put a compass rose on a given map, or if you would reference other mapped known compass roses and how you would reference that between maps. Very interesting stuff. Not sure how that would work, but I do know that they say that it was derived based on a compilation of actual compass and direction bearings using a compass when you're at sea. So in all Praetorian maps share the windrose network characteristic. Yep. So I didn't even look. I don't know what a Catalan atlas is. Do you know what it is?
Yeah, Catalan. Again, I think that's actually a Spanish term, more territorial. I can't quite put my finger on it right now, but that's the way it occurs to me. Even though that previous map you were looking at before, you don't know what language that was, it sure looked a lot like older Italian.
Yeah, yeah. But also it looked like Latin a little bit. It was weird. So I didn't know. Oh wait, hold on. There's this one. And so if this is a type of atlas then and it looks just like a Portolan chart, then would I venture that all atlases prior to a certain year were then Portolan charts so that they all had this built in? That would be my guess. So this is a little bit different, double hexadecagon planisphere, which essentially is just the same Portolan charts with compass roses when someone drew two spheres on it. This is funny. This is not how map projections work, but it's cool. This is it a little bit blown up. It's a really high quality Arctic Circle map, right? And again, right in the smack dab in the middle, what do we find? Compass rose. And if you look closely, what do we see? Windrose network. And what do we have on the point of these circles? That each one of these is actually a compass rose. No way. So even when they're trying to make it first spherical and trying to use what they're trying to tell us is a double planisphere projection, They're still using this basic planar sailing technique of compass rose as constant bearing and straight lines. Crazy. Here's a even better one. You can almost read it. These are straight from Wikipedia and super high quality.
You mean they've been doing plain sailing the whole time?
Like almost the whole time. Yeah. Like actually the whole
Unlucky.
time. Yeah. The whole time. Until modernity, when they had to do like right ascension, hour angle, celestial triangle transformation. That's the only time that people had to sail as if the earth was a sphere.
Oh, you mean the time they bound all the angles to the stars to time using a fictitious observer? Yeah, that's wild.
Yep. And then just put everyone in spherical coordinate systems and calculate everything that way. Boom. Double sphere model realized. But yeah, these maps are crazy detailed, and it's funny that Wikipedia has such like the original super high quality 12 megabyte downloadable image file, but no fucking idea where it came from, who used them, where it came created from, how long they were used, when they got swapped out for the sphere model. I find that interesting juxtaposition as well. And here's just the same. It's a little bit spread out, so we can see. But look how many compass roses are on this network. If you had to pick a spot where you'd put them, it'd be all along here, right? They're at all the important junctions, at all the important coastlines. They connect to all the important sites, almost as if you would take what Ptolemy did with his geographia and his coordinates of GPS and long lat, put in great use. It's almost as if they took those known locations that everyone knew where to find and made them the points for the compass rose so that you could navigate to them using your constant compass direction. So, again, if prior to 1600s, and this is from the 2nd century BC in ancient Rome and Greeks all the way to prior to Mercator, so 1600, if everyone was sailing fine with their nautical petroleum charts, with their wind rose networks, compass rose with a compass, and basic celestial navigation following latitude based on the stars, then the question becomes, lads, when did they actually create the globe? Like, when do we have the globe? When was this part of all of history? Because, again, we started with always, right? It's always been this way, except nobody's ever treated it that way up until 1600 when they made the Mercator. And even then, that didn't change how they treated it, but we'll go into that in just a minute. Real quick, there's a clip I stole from Steve at Spacebusters, who put out his video, I think yesterday, Scamtarctica with the Fantasy Island, which is a 3-hour feature-length film on a bunch of Antarctica stuff. But he was talking about maps, coordinate systems, longitude, transforms, and old school longitude. So I found it very interesting. And from that, I clipped this little bit where he talked about the very first globe, which is what the globies always say is, if you created this, if this was a lie created in the 1700s, as I'm about to argue, then why do we have models in 1482 in this guy, right? Like, why was Christopher, like, all the stories they'll come up with? And this little clip, I think, answers it nicely. So it's like a 2-minute clip. It's got sound. We're going to watch it now.
Not so fast, the globies say. We've known the Earth as a globe since at least 1482, since we still have Martin Eardopfel's actual globe, shown for real here, 62 years before the 1540 formation of the Jesuits you claim invented this model. A great point, and I noticed that Africa, Southern Europe, and a small bit of the Middle East to Western India take up half of the entire Earth on his globe. So I wondered how the other 3/4 of the known Earth fit on the backside of this globe. So I found an antique map dealer who has the entire thing. There's the front side we saw. The back side of the globe is East India into Southeast Asia and Indonesia, up to Tartaria. But that's none of my business, with Southeast Asia mapped out almost as large as Africa. So the red is one half the globe, the yellow is the other half of the globe, and even though Southeast Asia in yellow is just east of Africa in red, apparently if you sail due west from Africa, you come right back to Southeast Asia across the ocean. So everything in red just doesn't exist. But some guy in 1482 fit everything in blue and green on a basketball in a metal stand, and that's how they knew we live on a globe? How, pray tell, did they map out this globe and miss 3/4 of everything on it? Because, Steve, you idiot, they didn't discover the West until Columbus in 1498 when he sailed for the West Indies. 16 years after this globe proved there was no West Indies. Then why did he bother sailing west just to get back to Indonesia? So you need to shut up and stop claiming the ancients thought we lived on a globe, as the oldest globe we have is as recent as 1482 and was not even 1/3 of the known Earth all the way around it. You can't map an alleged globe you've never even been around to clearly see it's wrong and impossible.
If you only give them a certain amount of land and you wrap it around a ball with infinite repetition, then look, this is how far you can go. This is all we know. This is all we've seen. That makes a lot of sense. But so then the question we're chasing again is, when did they create the globe? Well, a period that I would like to start with is the 1714 Longitude Act, right? This is for a long time what I've been pointing to as, hey, this is, if you need a coordinate system to have the globe, then this is when they finalized and then mandated the coordinate system. This is a pretty good way to check it out. However, there's some discrepancy with the veracity of the source of the information here when we look into where it's coming from. And again, it's from the University of Cambridge, from the Royal Greenwich Observatory Archives. And it's this big launch called the Papers of the Board of Longitude. And it has 68 volumes of the so-called papers. This is what they look like. Document how all of this publicly institution's remarkably wide-ranging activities for over a century, culminating in the 1714 Longitude Act, when they nominated and empowered themselves to make laws and mandate coordinate systems. Right, their official tasks were to judge proposals for determining longitude at sea, to fund experiments to try what seemed like viable projects, and reward schemes judged successful according to the Act's stringent criteria. Well, isn't that super vague? And I guess scientifically grateful, right? Because the current disposition of these archives is due to the 19th century astronomer George Airy, a dude we're well familiar with, who, no matter what we do, keeps cropping up into everyone's presentations. That's crazy. Member of the board when it was abolished in 1828. Of course, it's divided up between the Admiralty and the British Society. So we reference this act, this Papers of the Board of Longitude, this time frame. And what I always say is that all of the known information that we have, this archive right here, these 68 volumes, or digitized all at once out of the kindness of their heart and altruism, I guess, from the University of Cambridge in the late 2010s, I think. Let me see. Yeah, so they were gathered and transferred to Cambridge University, where they became part of the archive, and then at 68 volume, which was digitized through 2010. So I think 2013 is when they dropped this to the internet and the people at large and suddenly made it available to the public. So everything that we're about to go over as far as the history of longitude, the Royal Society, how the Board of Longitude was created, and we're going to go through it really quick. All of this information comes from this one digital archive put forth from the University of Cambridge at the Royal Greenwich Observatory Archives as an act of kindness, digitized all at once from our wonderful benefactors and overlords. It's funny when you start looking into stuff that you keep finding all the same people. And when you're trying to span a history of 2,000 years, and you can see how some of it lines up and is, congruent, and some of it is not. And it's quite clear when you start to look at it in its entirety or in aggregate. So over here is just a summary of what you'll find when you go to the digitized archive of the Board of Longitude at the Cambridge University, put forth by our friends at the Royal Society, etc. And all of these are pretty much the subject, right? So the first one is our Exemplar Boy papers by George Biddle Airy, all of his personal papers. Now, I've been through some of these stuff. I looked at the originals, and I'll tell you, reading Geographia from Ptolemy, supposedly from 2nd century BC, was way easier to understand than the 17th century Old English that's in these old vellum parliament documents of these people trying to say stuff, okay? It's almost a completely different language to read this originally. To be honest, it's weird. If you remember, there's the decree about the Board of Longitude and the money that they put forth. Reading that is rough as heck, and that's been generously translated, right? So to think that there's such a disconnect with papers written 200 years ago, but I can gel seamlessly with documents from antiquity on 2,000 years ago, that's a little incongruent to me as well. If the progression of language works like that, then how is it, that it's so far away 200 years ago, but I could easily read Ptolemy, Hipparchus, and Eratosthenes like no one's business.
But hey, trust me, bro.
Like, that's just something I noticed trying to read these documents and then trying to read geography from Ptolemy, and one was very easy and one was all these are very hard. Some of the subjects here that are interesting: transits of Venus, right? They are the Royal Greenwich Observatory, National Maritime Manuscript, papers of the Board of Longitude is where I spent most of my time reading here. Papers of John Pond. I didn't even go there. I don't know who that guy is, to be honest. But all of these things were here. So they do make it always seem like it's just in the interest of everyone, for all of humanity, for the good of science, spurring on creation. It's like, so a bunch of rich people nominated themselves governors, doled themselves out power to make dictates, and then inflicted that upon you guys. Is that not what I read? Hold on. It's like, no, for the good of humanity, we got ourselves together, we made a board, and we took some treasures.
But wait, you forgot exploit the intellectual property of the masses.
Oh yeah, that contest where you can bring us your stuff means that we own your IP, and if it works, we're gonna make money, and if it's not, we'll just kill you. Yeah, imagine everyone parading in for that line. For sure. So, what that mentioned is our boy here, John Harrison. Right, John Harrison is the savior of the globe, who created the marine chronometer, who solved that problem that we just heard presented to us with its tidy solution called the longitude problem. Right. The longitude problem, of course, was that nobody all of a sudden could navigate at sea because there were accidents everywhere all the time. Or maybe there was just this one accident that we kept talking to everyone about more and more and more to try and drum up some fear, right? So before the establishment of the board, they said that they needed the longitude because ships were just crashing into the land, all like this ship's going down. No one knew where they were going, and they needed a way to unify longitude across a broad scale, just because. And then what they mentioned was this one error, this one shipwreck over here. They say typically they mention this one. A key catalyst is this silly naval disaster of 1707, where 4 ships and 2,000 men were lost after fleet miscalculated its position in bad weather. So they look, actually, this is because there was the inability to fix longitude and the errors in dead reckoning. So remember all these charts that everyone was using. All of a sudden in 1712 and 1709, none of these worked anymore. And all of a sudden was a need to refine what was put forth by our boys Ptolemy, Hipparchus, and Eratosthenes 2,000 years ago, but has sat dormant ever since. This is the actual historical timeline, right? So, lo and behold, our hero, John Harrison, produces the marine chronometer, which is the ability to keep time at sea. Now, the other component they mentioned was the creation of the astronomical almanac. So they were looking at positions of stars and using the positions of stars and what time it was, because all the stars rotate above Earth at 15 degrees per hour. They can then use that to get predictions and actual longitude to see where they are. If they know what time it is, then they can guess where they are on the world, right? So they can get to better accuracy, exploit the nautical lines that they're making on their charts. So, what did I write here? So, chronometers are precise. Yes. Right, 15 degrees per hour is exactly how they can convert longitude to degrees of measurement. So with this, they can actually use what's in the nautical almanac, right? So this is, of course, revolutionized navigation, saved all the accidents that were definitely happening all prior to 1700, and had an impact across Britain and enabled, East India Trading Company and all of the expansion of the trade network. Like, all of history can now proceed safely because of our boy John Harrison and the British Crown. But mostly because of John Harrison, right? Because he did this, even though these people were sitting in a room telling everyone what to do and who could work. Now, again, there was a longitude problem, but before we had just learned that they could determine longitude at sea. So they had methods prior to having to resort to the Board of Longitude. They had regular dead reckoning from their nautical charts with the assistance of compass rose and real direction bearing. Celestial navigation using local time, right, before they just had star locations. Lunar distance method, timing how fast or what stars would be occluded by the moon, and then using that as a measure of time. Eclipses and regular occultations would also be a form of time, but it's rare, right? Moons of Jupiter they would use, which also had their own eclipses, which would be, if visible, could determine longitude and some sort of time, but again, impractical at sea. Magnetic variation and regular compass, again, to use with compass, wind rose networks, compass roses, and Portola charts. And then they had local time-based signals. So all of this was how they were using their regular charts to navigate without the assistance of the glorious board of longitude. And of course, there was other ways you can determine longitude, right? You can use the equinox. You can, the exact moment of equinox, you can use that relation at solar noon to determine the actual zero time, right? So again, everyone was sailing as if the Earth was flat and planar with Portolan charts all the way up to 1600, no problem. Everyone's moving along. They had a compass rose. They had a more or less chart, a nautical chart. They had a wind rose network telling them where to go, and they had stars to find out roughly where their latitude was. So using these tools, everything was fine until the board of longitude told everyone that it wasn't fine. And then all of a sudden, from that, we have created the spherical graticule, right? Once the board of longitude happened and they could determine longitude at sea, then they refined their model and they restricted everyone to that coordinate system. And from that point, all the maps were projections of the spherical graticule, right? The latitude, longitude grid put forth by the Royal Society, and then from that decree. So then we know from our recent presentations and the two-sphere model that we recently did was that the right ascension declination of the celestial sphere 1-for-1 equals the latitude longitude of the terrestrial sphere, right? The celestial and the terrestrial sphere are equal, and this is the backbone of modern CELNAV, right? They convert what they see, right ascension declination, to useful navigational geodetic coordinates, or a point within the latitude longitude graticule where they can reference on the Earth. Because again, latitude longitude grid lines are tied to these fictional spherical model of the terrestrial Earth via the geodetic datum that we know so much, like WGS84, which is a spherical ellipsoidal model, which is also functioned as a geodetic datum, which is the heart of all mapping, satellites, GPS, video games, etc. Right? That's where this fictional terrestrial sphere model comes from. But the position that we put forth is that latitude longitude was reverse engineered from sky and celestial observations. You can get latitude from observing Polaris in the north, and you can do the same thing with southern observations as well. You can determine latitude based on the sky alone. And then if you can determine longitude based on the sky, right, the timing of which they started to do with the Nautical Almanac, then you can see how this equals this, and that this conceptual model is just a mirror of this conceptual model, right? This one was made to mirror this one. These are both conceptual spherical models, and we look into geodetic surveying and the celestial theodolite and battle of the beams, and we know that when you look at just the Earth, all Earth measures flat, planar measurements all the ways through and through, and then you get geodetic surveying with corrections according to this spherical model inflicted on flat plane measurements. So the position that we put forth is if latitude and longitude was reverse engineered from celestial observations, then the concept of a spherical Earth exists only in corrections over long distances of planar measurements on flat Earth. So then the curvature of Earth is thus an illusion by astronomic and geodetic measurements artificially aligned with this with the graticule. Right, so this is the whole thing I'm putting forth. And like rum lines, latitude and longitude were redefined in modernity to specifically apply to the sphere. According to Wikipedia and the internet, you actually can't have latitude and longitude unless you're talking about the sphere. Even though in antiquity, of course, they just meant breadth or width, right? Latitude coming from latitudo or latus, right? Broad, wide, breadth or width. That's really where it came from. And then longitude meaning length or long duration, from longest or long, right? These are the general terms to describe length, width, and breadth. Length and breadth. That's it. That's what they were historically meant. But in modernity, right, they redefined this term as a specific north-south position from an angular measurement from zero. Right, that's what latitude means, and of course longitude defined an east-west angular measurement as defined from zero, and of course zero meaning from our boys at the Greenwich Observatory. So in modernity, latitude and longitude are spherical. No doubt about it, right? They are describing a spherical coordinate system, which is how we get our two-sphere model of the cosmos, right? They match the terrestrial sphere with the celestial sphere, and then that's how you get our model. So then the latitude and longitude are both spherical as a conceptual model, and they are, then we know they're based on hemispherical observations, right? A flat Earth with a hemisphere of observability around you means that you see things rise and set as they come and go. So as a celestial object approaches you and goes, it appears to rise, approach zenith, and then set. And that's what drives all of this conceptual sphericity. Because mathematically, for describing something hemispherically versus spherically, we describe it identically with math. The same math is used to describe both. You have an X, Y, and a Z position in 3D space with this hemispherical dome. The only thing that's different is you have another hemisphere below you that's also conceptual, right? That you'll never see. All observations happen in this hemisphere, but this lower conceptual hemisphere gets represented with a negative Z value. So it's the same way to describe it, except this Z becomes negative as it passes this zero. And that's how you describe negative coordinates. Things like a nadir, which is the opposite of a zenith, something that's the absolute bottom position, and it's a theoretical spherical coordinate position. This hemispherical view. So from that, we get a regular alt as observations on a hemispherical view, which we then contrive and place into spherical coordinates using a negative z-axis for right ascension declination. So we have our second conceptual model, and then we define it like this. So that's how modernity uses the spherical coordinate system to get this two-sphere model, and that's how they get celestial navigation to work, right? Because if the celestial sphere equals the terrestrial sphere, then conceptually, right, for every point on the Earth, there is a unique point in the sky. And then for every point in the sky, there's a unique point on the Earth given a specific time, because all of the stars rotate around the Earth at the same declination or latitude line. And the only thing that changes is what time they'll be there, right? So that's where you get 360 degrees from a circle and 15 degrees per hour to get those angular coordinate transformations. So this is what produces a ground position, right? If you're going to create a ground position for a celestial object, you first have to map where it would be in the sky for its position on the ground. This is the backbone of celestial navigation. It's how you create a GP of a star, right? The geographic position or the subsolar point or the subpoint is the unique point on the surface where the star is directly overhead at zenith at a given instant. That is how they create these models. Right, the GP is calculated using the celestial coordinates and the local time. So using its angular distance north or south of the celestial equator, directly equivalent to latitude, and they use that to convert to get its GP on the Earth. Of course, the shorthand for these spherical to spherical modern celestial cell nav coordinate system is the hour angle transformation, right? The angular distance measured westward from the Greenwich meridian to passing through the star's GP. And then you get measured west from the ground, which is 0 to 36. So you do an hour angle transformation. And these two spherical coordinate systems are supposedly how everyone navigates the sea in modernity, right? So nowadays, everyone who navigates uses the two-sphere model of the universe. Now, the thing we haven't made clear then is, when did it switch? Or, first of all, when did the term switch, right? Latitude and longitude, as we were saying, has a different definition in modernity than it does now. And when did it start to mean something else? Well, unsurprisingly, 16th and 17th century, all these terms changed. So, right at the same time where we have the fabled Mercator projection that supposedly revolutionized cartography and led right to the globe, right up until then, it meant breadth and width, length and width, right? And then when we have this map and we have this coordinate system and everyone's trying to make ellipsoidal models in the 17th century, then now we've redefined latitude and longitude as applying to a spherical graticule. Very interesting. Of course, they also refined it and put the rubber stamp on it by 1884 in the International Meridian Conference. Latitude and longitude were eventually in the books as angular measurements on a spherical Earth. So that's when that happened. But when did we switch from plain sailing to globe sailing? I must have missed it, because through all of modernity, for all of antiquity rather, we're sailing on plain sailing using regular planar maps, compass rose networks, etc. Right? So the timeline here is, everyone knew that the Earth was a sphere and that everyone understood the two-sphere model in antiquity, but nobody sailed that way. Everyone used plain sailing. all the way through the Middle Ages. So from 200 BC to about 1600, everyone knew that the Earth was everyone knew the Earth was a sphere and that the stars were a sphere, and everyone accepted and understood Ptolemy's two-sphere model, but nobody used it for anything, and all the maps and the Portolan charts were used on flat plane elevation. Okay, cool. So from the 14th to the 17th century, or they're saying from about 1300s, everyone was using Portolan charts. So again, arguably, I guess, everyone still understood that the Earth was a sphere here, but had decided to ignore that to use these Portolan charts specifically based on observations, compass bearings, compass rose networks. Going to forego a longitude grid. No one needed that from 1300 to 1700. Apparently, we needed it beforehand, but nobody used it, right? We had to know that it was there, but nobody employed it. This is the actual timeline. Not poking fun, just trying to get the actual mainline story out. And then you roll right into 17th and 18th century when we have the longitude problem, the board of longitude, high-profile disasters like this single one that everyone mentions all the time. And then we have the celestial terrestrial model being accepted. So all of a sudden, it's always been there. That's the timeline. Up until 1700s, that's when we needed, to use the spherical model of the Earth because of this single this single accident led to us having to solve the longitude problem, and that's when we could no longer use our Portolan charts and nautical references and compass roses. That's crazy. This is the
What a
actual
fish story.
like this is and wait till we get to the first Mercator. So the reason that the Mercator is so important is that apparently it revolutionized map making. What it was, let's listen to the definition of what it accomplished, right? Designed so that straight lines on the map represented lines of constant compass bearing. Wait a second. What was a rum line again? Isn't that exactly what the rum lines and the Portolan charts of old that we were looking at were? That's exactly what they were. So the point of the Mercator is to recreate what everyone was already doing? Wait a second, no. So historically, I always thought about, well, I know the Mercator projection today is a cylindrical projection at a specific graticule that you have to have, the spherical coordinate system of latitude, longitude to work with. So couldn't possibly be that accurate if it was already the globe. The problem with that, though, is in 1516, there was no coordinate system, right? We went through the board of longitude, solving the coordinate system in 1714, putting it into effect in late 1800s for all of modernity. However, what were they using then? What did Mercator use to make his projection then? Apparently, he invented a new cylindrical projection of a spherical graticule, but it was made to use it exactly mirror all the rum lines of old. So it preserved angles, making navigation by compass much simpler. Again, this is exactly what the old rum lines were doing in the old nautical maps with the Portolan charts were. So when we look into it, this is what I would think of as the Mercator projection. This is what I would have thought Gerardus Mercator invented. Was this projection? This comes with its own unique mathematical transform, which would be so a cylindrical conformal projection means that you stretch the spherical graticule in a way that was allowed to project in the equal meridian lines of less equal area distortion from which you can make constant line drawings. That's the actual definition of what that math would represent, right? It represents this, where in the middle, not so distorted. On the edges, super fucking distorted. That's all that means. So when we're saying that this changed everything, what we have to look at then is, well, what did it look like? What was Gerardus's Mercator map of 1569? What did it look like? Because after 1600, everything changed because of this. And prior to this, everyone thought the Earth was a plane and was using compass roses. And so this must be the point where we switched to the spherical graticule and started using long lat and made use of Ptolemy and Eratosthenes and Hipparchus and what everyone did. Well, let's take a look at it. Here it is. Here's the first Mercator map. Gerardus Mercator from 15. Well, wait a second. What is all this shit? Are these compass roses? Is this a wind rose network? Is this just a more defined evolution of an old school Portolian chart and in no way a spherical distortion graticule? Wow. Look at that. That's crazy. You can tell that the lines here are variously distorted, right? If this is the grid lines that he drew on there, then we can see that matches what we had over here. right? As opposed to the distortion. That that would be it. But what the actual first Mercator map was just an evolution of these old school charts, right? Portolan charts with compass roses. If you look at it, it's just this, but more. He even has them in some of the same points, right? The lower part of Africa over here. Remember this part. Remember what our old school navigation, plain sailing techniques, and maps and nautical charts looked like. And then our brand new spherically inclined graticule honoring Mercator cylindrical conical cylindrical conformal projection. Neat, right? or it could have went the other way. All right, now of course the title here does say let's see, Nova et Octa Orbis Terrae description is ad usum navigatatum. What's that? MD? I don't even know. Translates to a new and more complete representation of the terrestrial globe properly adapted for use in navigation. Is that the actual title of this map? So it's an actual effort to make the globe out of a flat map, right? I'm going to create a representation of the terrestrial globe. That's what this is called, but it's using all the rumline networks and the compass rose from the old school Portolan chart. So again, trying to wrap it up here with the timeline. Let's go through it one more time. So 3rd century BC, Eratosthenes has everything mapped out, latitude, longitude, measured the size of the sphere using sun angles. Everyone set, no one questioned, everyone knew. 100 years later, Hipparchus formalizes 360 division, gets you systematic coordinates, pumped in time for our boy Ptolemy, who creates geography, also known as cosmographia, and literally writes the detailed instructions for graticule drawing and the two-sphere modeling. So we went from 3rd century to 2nd century BC. We have all of the tools for sphericity ready to go, except from 2nd century to 16th century, everybody fucks off. Nobody pays attention. Everyone ignores this. Everyone sails as if the earth is flat, uses plain sailing, compass rose, wind rose networks, constant compass bearings, and dead reckoning with celestial observations. That's how everyone did it for 1700 years, even though everyone knew it was a globe and that everyone had the tools to do so. And again, up until the 18th century or late 1700s, all of a sudden we had an accident. 2,000 people died. 4 ships went down. Now we need to standardize all of naval navigation to a spherical graticule and this coordinate system, Board of Longitude, Royal Decree, Crown, Royal Society, Cambridge, etc., etc. 1884, final global standardization, pun intended, right? So here's the actual historical timeline of how we got the globe.
In 1901, they discover a shipwreck in Antikythera, Greece, that has a portable analog computer on it that essentially could predict celestial events and timing, that dated back to 200 years BC.
But they needed a chronometer for that. That can't possibly be. John Harrison saved that ship.
I mean, what a fish story.
Yeah, to have an Antikythera mechanism is like a supercharged, even an astrolabe is a, super advanced tool for astronomical observation. Literally functioned as a planisphere, could take celestial meridians, could definitely check out the phase of the moon, the arc of the moon, the 3, where the node was, when the last eclipse was. You can tell all that from your ship, but nobody could do shit until John Harrison made a watch.
Right.
That's the story.
Right. Yeah. And they needed something that was portable. Oh, guess what, boys? It was very portable because they found it on a Greek ship in 1901. Must have crashed around 200 BC. So it was very portable because it was on a ship. And if it was on a ship, it was probably being used for celestial navigation and timing. And amazing.
So once I saw this is the first time I ever looked at the original Mercator, because again, whenever I heard Mercator, my map projection, when I always play with the map projections, I'm just thinking, oh, this is the Mercator. And I'm thinking, how did a dude in 1500 invent this prior to this? Prior to the thing being transformed, prior to the graticule, prior to the the dude invented the math to transform conical projections of a sphere, but no, I couldn't figure it out. And then I looked at it and I was like, oh, duh. Yeah, this is just an improvement over the old school nautical maps with almost zero adherence, like the thing, right? If you look closely, it's got the artistic thing. Some of the other famous Gerardus Mercator maps is our favorite North Pole map, where it creates, Rupus Nigra, the black rock at the center of the four signs. He's famously known for the first map to create that. And when we look at it, I think it's on here somewhere. Actually, no, I've looked at it before. but he is also famous for that depiction. So he's using artistic depictions here. He's got outlays, inlays. He's got all sorts of fancy stuff. But he's also using wind rose networks and compass roses and constant bearings of plane sailing. You can see over here, he's got all these islands mapped out. So, I mean, to tell me that this is the first actual spherical map and then have it look identical to all the other planar Portolian charts that I've ever seen is hilarious. Because obviously,
Can
with
you
the
go
other
back? Can you go back and zoom into the lower left of that map? Pretty sure we were looking at Antarctica down there.
over
Is that
here,
what that is?
Yep, yep.
Nice.
Son of a
He's
bitch.
also got sun angles and how sun angles work on a sphere over here, right?
What year was this again? Did he make this?
1569, I think.
Yeah.
1569. I was first thinking, oh look, the guy created the map that didn't properly scale the continent sizes. Like, way to go! But then I finally saw it, and I was like, oh, none of that's happening. Like, this could easily people have just drawn this grid on. Like, the only thing spherical about this is the way that this square is bigger than this square, because that matches the conformal projection type, and that's what I'd be looking for. But it's mostly this. He's just made an old school map. So again, if we were looking at ancient maritime navigation, the timeline is shit. It's obviously something has been inserted. And if I were to bet man, I would say the antiquity part of how everyone always knew it was a sphere forever is probably bullshit. I would think everyone navigated as if it was a plane up until 16th century, regardless of what they thought they knew. And then all of a sudden, everyone knew that it was a globe. And then I think what happened was after the Mercator, and they could adequately get true compass bearing directions within this non-distorted grid, from then they can actually derive what would be the quote correct directional bearings on a sphere, and from there they could actually get the globe and refine the coordinate system so that these lines of constant bearing within here, replacing the old school rumline networks, could get a better collection of observations for true quote true direction bearings to landmarks. And from there, easy sailing right to your coordinate system, right to your Clark ellipsoid model of 1718, right to the refinement of the WGS84 through satellites, interferometry, radio, all that good stuff. So that's how we get the globe in modernity, and that's pretty much all I had. And it existed, but it wasn't that good, and Mercator made it better, and only true rum lines are straight only on a Mercator projection. That's what its final ultimatum is. So we forgot to touch on this, but the modern definition of a rum line, like I said, specifically ties to a sphere, and only the Mercator demonstrates the spherical definition of a rum line. Therefore, it's right. Man, some backwards ass circular logic there.
The benevolent Royal Society that just wanted to help everyone out.
Yeah, if you look into them, they're like the best thing ever. They help everyone. They've never done anything wrong. It's so funny the way that they credit themselves with stuff. But if you read between the lines, you're like, wait, so you guys awarded yourself a bunch of power, paraded it over the citizens, forced them to do your bidding, held a contest for your own amusement, pirated all the IP, and then bowed and said thank you? Like, what?
I have a quick question about, you mentioned spherical graticule a few times. I've never heard that term. How does that relate to the graticule? Is that just they just add another hemisphere? Or?
Well, so the graticule is a term I like to use a lot. It just means the spherical grid of latitude, longitude. A lot of people confuse what is the graticule with like the Earth, right? Because they're like GPS works, WGS84. It's all the ellipsoidal model, which operates as one half of the two sphere model. So the latitude, longitude grid, also known as the graticule, is exactly the terrestrial sphere part of the two sphere model. Well, that is to say, a completely made up conceptual spherical model of the Earth made to mirror the sky.
Here?
So, you know how the terrestrial sphere is confirmed, right? They quote measure meridian arcs, meaning that this line right here from the North Pole to the equator is a quarter terrestrial meridian. And how we're going to absolutely measure the length of this bad boy is we're going to go right here. We're going to measure 1 kilometer with a chain gang and a bunch of planks. 1 kilometer either way. Of course, we're going to measure about 1,000 meters, right? And you can't tell if the Earth is a sphere, a plat, or a freaking hexagon at 100 1 kilometer. But we're going to measure 1 kilometer. We're going to look straight up at where the stars are. We're going to calculate the rest of this bad boy based on our astronomical latitude. and boom, we've confirmed our terrestrial sphere.